Researchers have proposed the first graphene synthesis technique that utilizes carbon monoxide as the carbon source. It is a fast and cheap way to produce high quality graphene with relatively simple equipment for use in electronic circuits, gas sensors, optics, and beyond. The study came out in the journal Advanced Science. Chemical vapor deposition is the standard technology for synthesizing graphene, the one atom thick sheet of carbon atoms in honeycomb arrangement with unparalleled properties useful for electronics applications and more. CVD usually involves carbon atoms breaking off gas molecules and settling on a substrate as a monolayer in a vacuum chamber. A popular substrate is copper, and the gases used have invariably been hydrocarbons, methane, propane, acetylene, spirits, etc. The researcher says that the idea to synthesize graphene from carbon monoxide came a long time ago, since that gas is one of the most convenient carbon sources for the growth of single-walled carbon nanotubes. The researchers have had working experience with carbon monoxide for almost 20 years. However, their first experiments with graphene were unsuccessful, and it took them a long time to understand how to control the nucleation and growth of graphene. The beauty of carbon monoxide is in its exclusively catalytic decomposition, which allowed them to implement self-limiting synthesis of large crystals of single-layer graphene even at ambient pressure. The new method benefits from the principle of so-called self-limiting. At high temperatures, carbon monoxide molecules tend to break up into carbon and oxygen atoms when they come in close proximity to the copper substrate. Yet, once the first layer of crystalline carbon is deposited and separates the gas from the substrate, this tendency subsides. So, the process naturally favors the formation of a monolayer. Methane-based CVD can also operate in a self-limiting manner, but to a lesser extent. The researcher says that the system they used has a number of advantages. The resulting graphene is purer, grows faster, and forms better crystals. Moreover, this tweak prevents accidents with hydrogen and other explosive gases by eliminating them from the process altogether. The fact that the method rules out combustion risk means that no vacuum is required. The apparatus works at standard pressure, making it much simpler than conventional CVD equipment. The simplified design, in turn, leads to faster synthesis. It only takes 30 minutes from taking a bare piece of copper to pulling out the graphene. Since vacuum is no longer needed, the equipment not just works faster but also becomes cheaper. Besides the standard applications of graphene as such, there are intriguing possibilities for using graphene bound to the copper substrate without clearing away the metal. Compared with methane, carbon monoxide has a very high energy of adhesion to metal. This means that as deposition occurs, graphene both protects the copper layer from chemical reactions and endows it with structure, creating a highly developed metal surface that has great catalytic properties. Some other metals such as ruthenium and palladium would also work in this context to open an avenue for novel materials with unusual surfaces.